From a paper cut at work, to food poisoning at Chipotle, to that flu your coworker gave you by breathing near your face, this is how your immune system actually fights infections, and the brutal tactics it uses to keep you alive. And spoiler, while some defenses are genius military strategy, others are why you almost died from a peanut. But first, let's talk about what's happening inside your body right this second. Because while you're sitting here scrolling, your immune system is waging microscopic warfare against billions of invaders trying to kill you. We're talking bacteria, viruses, fungi, parasites, all sneaking past your defenses every single day. And your body? It's not playing nice. It's deploying chemical weapons, sending in suicide soldiers, and literally eating threats alive. Pretty metal for something you can't even see. So buckle up, because we're about to dive into the most insane biological battle you didn't know was happening inside you right now. You get a paper cut at your desk, barely notice it, keep scrolling through Instagram. No big deal, right? Wrong. Because in that exact moment, you just opened the gates to hell. Thousands of bacteria living on your skin, specifically Staphylococcus aureus and Streptococcus pyogenes, just got a VIP pass into your bloodstream, and they're not here to make friends. Within seconds, your body notices the breach. Think of your skin as a fortress wall that just got cracked open. The first responders? Mast cells hanging out in your tissue, basically the guard dogs of your immune system. They immediately release histamine, which is why the area around your cut turns red and starts swelling. That's not damage. That's your body sounding the alarm. About 20 minutes later, neutrophils arrive on the scene. These are your immune system's drunk Vikings. They don't ask questions. They just start eating everything in sight. Literally. Neutrophils engulf bacteria through phagocytosis, which is a fancy way of saying they wrap around the invaders and dissolve them alive with enzymes. Pretty metal. But here's the thing. Neutrophils are kamikaze soldiers. They fight so hard that most of them die in the process, and their corpses pile up at the infection site. You know what pus is? Dead neutrophils. That white-yellow gunk oozing from your cut? That's a graveyard of immune cells who gave their lives to save yours. I'm not crying, you're crying. Meanwhile, macrophages show up to clean the battlefield. Their name literally means big eaters, and they live up to it. They consume dead neutrophils, destroyed bacteria, and damaged tissue, basically playing janitor, while also releasing cytokines that scream, "We need more help," to the rest of your immune system. This is also why you feel pain and heat around the cut. Inflammation isn't a design flaw, it's a feature. The heat actually helps kill bacteria because many of them can't survive higher temperatures. Your body is literally cooking the invaders. Genius or psychotic? Both. And get this, for 99% of infections, the battle ends right here. Your paper cut heals in a few days, you forget it ever happened, and those neutrophils died heroes. They died so you could keep double tapping Instagram posts without developing sepsis. Pretty crazy when you think about it. But you know what happens when it's not just a paper cut? So you ate gas station sushi. Questionable choice, but we've all been there. Maybe you were on a road trip, maybe you were broke, maybe you just make bad decisions. Either way, about 6 to 12 hours later, you're about to regret everything. Because unlike that paper cut with a few thousand bacteria, you just swallowed millions of Salmonella enterica, or Escherichia coli. And these aren't just hanging out on your skin, they're in your gut, multiplying like crazy, releasing toxins, and turning your intestines into a war zone. Your body's response? Go absolutely nuclear. First, the complement system kicks in. This is a chain reaction of over 30 different proteins in your blood that basically tag bacteria like, "Kill this," and punch holes in their cell walls until they explode. It's called complement because it complements your other defenses, but really, it's just biological warfare at the molecular level. Then your brain gets involved. It detects the infection and deliberately cranks up your internal thermostat, giving you a fever. And yeah, it sucks. You're sweating, shivering, feeling like death. But that fever? It's on purpose. Most bacteria thrive at normal body temperature, but start dying off when things heat up to 102 degrees Fahrenheit or higher. Your brain is literally cooking the invaders alive while you're wrapped in blankets wondering why you ate that spicy tuna roll. Here's where it gets wild. Your immune system releases cytokines, specifically interleukin-1 and tumor necrosis factor alpha. Don't worry about the names. Just know they're chemical messengers that make you feel absolutely terrible. The fatigue, the body aches, the total lack of energy. That's not the infection. That's your immune system forcing you to lie down and stop moving so all your body's resources can focus on the fight. Pretty smart, actually. But the most brutal defense? Your body just decides to purge everything. Vomiting and explosive diarrhea aren't bugs, they're features. Your intestines are basically saying, "Get this stuff out," and forcibly ejecting millions of bacteria before they can do more damage. It's violent, it's unpleasant, and you lose your dignity in a gas station bathroom. But you're also losing the infection. Meanwhile, dendritic cells are playing spy. These are immune cells that grab samples of the bacteria, like scouts gathering intel on the enemy. They travel through your lymphatic system to your lymph nodes, which is why sometimes your lymph nodes swell up when you're sick. Those dendritic cells are reporting back to headquarters with information about what you're fighting. And this is where things transition from brute force to actual strategy. Because those dendritic cells are about to activate something way more sophisticated than neutrophils just eating everything in sight. They're about to call in the special forces. While neutrophils are basically drunk Vikings pillaging everything in sight, T cells are the Navy SEALs of your immune system. Elite, trained, and scarily effective. And they're about to take this fight to a whole new level. Remember those dendritic cells that grabbed intel? They've arrived at your lymph nodes, which are basically training camps scattered throughout your body. And this is where adaptive immunity begins. This is where your immune system stops reacting and starts strategizing. First up, helper T cells, also called CD4+ cells. These are the quarterbacks calling plays. When a dendritic cell presents them with fragments of the bacteria, these T cells analyze the threat like a general studying enemy tactics. Then they release signals that activate two other crucial players, killer T cells and B cells. Killer T cells, or CD8+ cells, are exactly what they sound like, assassins. But unlike neutrophils that just eat everything, killer T cells are precise. They hunt down cells in your body that are already infected and force them to commit suicide. Apoptosis, if you want the fancy term. Basically, they make infected cells self-destruct before they can become bacteria factories. Cold-blooded, but effective. But the real stars? B cells. These guys produce antibodies, and antibodies are legitimately one of the most insane things your body does. Picture a Y-shaped protein. The two arms at the top are specifically designed to grab onto one exact part of one exact pathogen, like a lock and key. Each B cell makes antibodies for one specific target, and when it finds that target, it clones itself millions of times. One B cell becomes an army of identical B cells, all pumping out the same antibody. And these antibodies? They're brutal. They coat bacteria like sticky notes that say, "Eat me," so macrophages can find them faster. They block viruses from entering your cells. They clump pathogens together so they're easier to eliminate. They even activate that complement system to blow holes in bacterial cell walls. This is insane when you think about it. Your body can produce antibodies for literally billions of different threats, including ones that don't even exist yet. It's like having a weapons locker with a custom gun for every possible enemy, even hypothetical ones. But here's the craziest part. Some of those B cells and T cells become memory cells. They stick around for years, sometimes decades, just waiting. If that same pathogen ever shows up again, your immune system doesn't have to start from scratch. Those memory cells recognize the threat instantly and mobilize within hours instead of days. This is why you usually only get chickenpox once. This is why your second bout of the same flu is way milder. Your body remembers. It learned. It leveled up like an RPG character grinding experience points. The whole adaptive response takes about 7 to 10 days to fully activate. That's why you feel sick for over a week with a new infection but bounce back faster from repeat exposures. And this is exactly why vaccines work. Vaccines are basically showing your immune system the enemy's mugshot before the fight even starts. And when you understand how memory cells work, vaccines go from controversial to absolutely brilliant. Here's the thing. Traditional vaccines used weakened or dead versions of a pathogen. Think of it like showing your immune system a training dummy that looks exactly like the real threat but can't actually hurt you. Your B cells and T cells study it, create antibodies, generate memory cells, and boom. You're protected without ever getting dangerously sick. Then we got mRNA vaccines, which blew everyone's minds during COVID-19. Instead of giving you the actual virus, or even pieces of it, mRNA vaccines are literally just instructions. They tell your cells to temporarily make one harmless part of the pathogen, like the spike protein on coronavirus. Your immune system sees that spike protein, freaks out, creates antibodies and memory cells, and then the mRNA degrades and disappears within days. It's like sending your immune system a wanted poster instead of capturing an actual criminal. And yeah, you feel like crap after getting vaccinated sometimes. Sore arm, fatigue, maybe a low fever. But that's not the vaccine hurting you. That's proof your immune system is working. Those cytokines making you tired? That's your body taking the training seriously. The inflammation at the injection site? Neutrophils and macrophages rushing in to investigate. Your immune system is going through the entire response sequence, just without an actual dangerous infection. The payoff is incredible. Those memory B cells can stick around for decades. Some vaccines give you lifetime protection from a single dose. Others, like tetanus, need boosters every 10 years because memory cells gradually decline. But even then, a booster shot reactivates those sleeping defenders way faster than building immunity from scratch. Take measles. If you get the MMR vaccine, you have about 97% protection for life. But if you skip the vaccine and catch actual measles, you're looking at high fever, total body rash, and a 1 in 1,000 chance of brain inflammation that can kill you or cause permanent brain damage. Oh, and measles also wipes out your existing immune memory for other diseases, leaving you vulnerable to everything for years. So yeah, vaccine side effects for 2 days versus potential death and immune amnesia. Pretty easy math. The greatest vaccine success story: smallpox, a disease that killed 300 million people in the 20th century alone. We vaccinated so many people that the virus had nowhere left to hide, and in 1980, we declared it completely eradicated from Earth. The only disease we've ever eliminated as a species. That's the power of hacking immune memory on a global scale. But here's where the tone shifts, because sometimes your immune system doesn't just remember threats. Sometimes it remembers wrong. Sometimes it attacks things that aren't threats at all, or goes so overboard that the defense becomes more dangerous than the disease. Sometimes your elite defenders become the villain, and when that happens, the results are catastrophic. Remember how we said your immune system is a genius defense network protecting you from everything? Well, sometimes it's also the thing trying to kill you. And when your elite special forces turn against your own body, the results are absolutely devastating. Welcome to autoimmune diseases, where your immune system mistakes your own cells for enemies and launches a full-scale assault on your organs. Take type 1 diabetes. Your T cells decide that the insulin-producing cells in your pancreas are threats and systematically destroy them, every single one. Now your body can't regulate blood sugar, and you need insulin injections for the rest of your life just to stay alive. Thanks, immune system. Or rheumatoid arthritis, where your immune system attacks the lining of your joints, causing chronic pain, swelling, and eventually destroying the cartilage and bone. Your body is literally eating its own skeleton because it got confused about what's self and what's invader. Multiple sclerosis? T cells attack the myelin sheath, protecting your nerve fibers, which is like stripping the insulation off electrical wires. Signals can't travel properly through your nervous system, leading to vision problems, muscle weakness, and loss of coordination. Your own immune system is sabotaging your brain's ability to communicate with your body. About 1 in 10 Americans has some form of autoimmune disease, and we still don't fully understand why it happens. Genetics play a role, environmental factors trigger it, but the exact cause? Still a mystery. Your immune system just decides one day that parts of you are the enemy. But at least autoimmune diseases are chronic and manageable with treatment. You know what's not manageable? Allergies that kill you. Anaphylaxis is your immune system overreacting so violently to a harmless substance that it shuts down your entire body. Someone eats a peanut, their mast cells release massive amounts of histamine, their blood pressure drops, their throat swells shut, and they can die within minutes. All because their immune system saw peanut proteins and decided to go nuclear option. Peanuts, shellfish, bee stings. Your immune system treating them like they're the bubonic plague, when they're literally just food and insect venom that most people handle fine. The most insane part? It's the strength of your immune response that makes it deadly. This concept gets really dark when you look at the 1918 Spanish flu pandemic, which killed an estimated 50 million people worldwide. And who died the most? Not the elderly or young children with weak immune systems. Healthy young adults in their 20 and 30 seconds. Why? Cytokine storm. When the virus infected their lungs, their powerful immune systems released so many cytokines, specifically interleukin-6 and tumor necrosis factor, that it created a feedback loop. More inflammation, more immune cells, more cytokines, more inflammation. The immune response was so strong it drowned their lungs in fluid and killed them. Their defense system became a weapon of mass destruction aimed at their own respiratory system. Having a strong immune system killed them. Having a weaker one actually improved survival odds because the immune response stayed proportional to the threat. That's a design flaw that's hard to ignore. And we're still dealing with it today, just with different viruses and better medical understanding of how to fight our own immune systems to save lives. And in modern times, we've seen this exact nightmare scenario play out in real time. COVID-19 taught us this lesson the hard way. When SARS-CoV-2 infected people's lungs, some patients experienced severe cytokine storms. Their immune systems released so much interleukin-6, interleukin-1, and tumor necrosis factor that their lungs filled with fluid, their blood oxygen levels plummeted, and they ended up on ventilators, fighting for their lives. The virus wasn't killing them. Their own immune response was drowning them from the inside. And the treatment? Steroids like dexamethasone to suppress the immune system. We had to chemically restrain the body's defenses to prevent them from causing more damage than the virus itself. That's the paradox of severe COVID. The people who died weren't always the ones with weak immune systems. Sometimes they were the ones whose immune systems were too strong, too aggressive, too willing to destroy everything to eliminate the threat. This same problem shows up in sepsis, which kills over 270,000 people in the US every year. Sepsis happens when your immune response to an infection spirals out of control. Bacteria enter your bloodstream, your immune system freaks out and releases a tsunami of inflammatory signals, and your blood pressure crashes while your organs start failing. The infection might have started as something minor, like a urinary tract infection or pneumonia, but your immune system's overreaction turns it into a life-threatening emergency. Mortality rate for severe sepsis, between 30% and 50%. And the treatment is the same paradox. Antibiotics to kill the bacteria, but also drugs to calm down your immune system before it kills you. Then there's organ transplants, which are a whole different level of immune system drama. Someone gets a new kidney or heart, and their immune system immediately recognizes it as foreign tissue and tries to destroy it. Doesn't matter that this organ is literally saving their life. T cells see, not self, and launch an attack. So transplant patients have to take immunosuppressant drugs for the rest of their lives, deliberately weakening their immune defenses to prevent organ rejection. The side effect? They're now vulnerable to every infection that comes their way because we've handicapped their immune system on purpose. It's a brutal trade-off, but it's the only way to keep the transplanted organ alive. But here's where it gets wild. Scientists figured out how to flip the script and turn the immune system into a weapon against one of our deadliest enemies, cancer. CAR T therapy takes T cells out of a cancer patient's body, genetically engineers them to recognize cancer cells, then puts them back. These modified T cells hunt down and destroy tumors with terrifying precision. In some types of leukemia, CAR T therapy has remission rates over 80%. We're teaching immune cells to do what they normally can't: identify and kill cancer before it spreads. Because cancer is sneaky, tumors evolve ways to hide from the immune system, to camouflage themselves as normal cells, to shut down T cell responses. They're playing immune evasion on expert mode. But CAR T cells don't fall for the disguise. They're programmed assassins with one job: find cancer, kill cancer. It's not perfect. CAR-T can cause its own cytokine storms, ironically, and it's incredibly expensive, sometimes over $400,000 per treatment. But it represents a fundamental shift in how we think about immunity. We're not just defending against infections anymore. We're engineering immune cells to fight diseases they were never naturally equipped to handle. So how do we support this insanely complex, sometimes self-destructive, absolutely critical system in everyday life? Can you actually boost your immune system? Short answer, not really. Long answer, it's complicated. And most of what you've been told is complete BS. Vitamin C doesn't prevent colds. Studies show it might reduce the duration by like half a day if you're already sick. But taking massive doses when you're healthy does basically nothing. Your body just pees out the excess. Expensive urine, congrats. Echinacea, elderberry, zinc lozenges. The research is mixed at best, and most studies show minimal to no effect. Millions of people to spend money on immune boosters that don't actually boost anything. So what does work? The boring stuff your mom always told you about. Sleep is huge. When you sleep, your body produces cytokines that help fight infections and inflammation. Studies show that people who sleep less than 6 hours a night are 4 times more likely to catch a cold compared to those who sleep 7 or more hours. Your immune system literally needs downtime to function properly. Exercise helps too, but there's a sweet spot. Moderate regular exercise, like 30 minutes of walking or jogging most days, can reduce your risk of infections. But intense endurance training, like marathon running, temporarily suppresses your immune system for hours after the workout. That's why you sometimes see athletes getting sick right after competitions. Nutrition matters, but not in the way supplement companies want you to think. A balanced diet with fruits, vegetables, and protein gives your immune system the raw materials it needs. Vitamin D deficiency is linked to increased infections, so if you live somewhere without much sunlight, supplementing that actually makes sense. But mega-dosing random vitamins? Waste of money. Stress is a massive immune suppressor. When you're chronically stressed, your body releases cortisol, which directly inhibits T-cell and antibody production. It's why college students always get sick during finals week. Your immune system can't function at full capacity when you're running on anxiety and caffeine. And here's something wild. Your gut microbiome trains your immune system. The trillions of bacteria living in your intestines help educate your immune cells about what's dangerous and what's harmless. Eating diverse, fiber-rich foods feeds good bacteria, which in turn helps your immune system function better. Probiotics might help, but the science is still developing. But even if you do everything right, you're still facing threats your ancestors never had to deal with. Antibiotic resistance is a growing crisis. Bacteria like MRSA and Clostridioides difficile have evolved to survive our best drugs, and they're killing thousands of people every year in hospitals. We're running out of antibiotics that work, and bacteria are evolving faster than we can develop new ones. Then there's the constant threat of novel viruses jumping from animals to humans. COVID-19 wasn't a freak accident, it was inevitable. We've had SARS, MERS, Ebola, bird flu, swine flu. Viruses mutate, they cross species barriers, and our immune systems have zero memory of them. That's the nightmare scenario, a pathogen we've never encountered, spreading faster than our immune systems can adapt. Unlike smallpox, which only infected humans and could be eradicated, most diseases have animal reservoirs. We can't eliminate influenza because it lives in birds and pigs. We can't eliminate coronaviruses because they circulate in bats and other mammals. These viruses will keep jumping to humans, and our immune systems will keep fighting new battles. Which brings us to today, where right now, as you read this, your immune system is fighting wars you don't even know about. Right now, as you read this, your body is being exposed to billions of bacteria, viruses, and fungi. They're on your phone, in the air you're breathing, on every surface you touch. And your immune system is handling it without you even noticing. Every single day, your neutrophils destroy thousands of bacterial invaders. Your T cells eliminate cells that have been infected or have become cancerous. In fact, your immune system kills an estimated 1,000 to 10,000 precancerous cells every single day before they can become tumors. You're dodging cancer constantly, and your immune system is doing all the work. Your body contains somewhere between 25 to 40 billion white blood cells at any given moment. That's roughly 5 times the human population of Earth, all working in coordinated teams to keep you alive. And they're constantly being replaced. Neutrophils only live for about 5 to 6 hours. Your body has to make 100 billion new ones every single day just to maintain the force. The diversity is staggering too. Your immune system can theoretically produce about 10 billion different antibody types. That's more unique combinations than there are stars in the Milky Way. You have the molecular equivalent of a Swiss Army knife with 10 billion tools, ready for threats that don't even exist yet. And it never sleeps. Unlike your brain, which needs 7 to 8 hours of downtime, your immune system is on 24/7 surveillance, patrolling your bloodstream, scanning your tissues, analyzing every cell for signs of infection or mutation. It's the most tireless workforce in your entire body. The future of immunology is even crazier. Scientists are working on programmable immune cells that can be tailored to individual patients and specific diseases. CAR-T is just the beginning. Researchers are developing T-cells that can target multiple types of cancer at once, or that can hunt down HIV-infected cells that hide from normal immune responses. There's ongoing research into a universal flu vaccine that would protect against all influenza strains, instead of needing a new shot every year. Gene editing technologies like CRISPR are being tested to fix immune deficiencies at the DNA level. Some scientists are even trying to engineer immune cells that could extend human lifespan by better controlling age-related inflammation. But even with all this cutting-edge science, we still can't answer some basic questions. Why do some people never seem to get sick while others catch everything? Why do identical twins sometimes have completely different immune responses to the same pathogen? How do some people survive Ebola while others die within days? Your immune system remains one of the most complex and least understood systems in your body. We know how it works in broad strokes, but the details are still full of mysteries. Every answer reveals 10 new questions. But if you think that's crazy, I'll leave you with the most insane immune system facts. Your body makes 100 billion neutrophils every single day. Your immune system can recognize 10 billion different threats. You're exposed to enough pathogens daily to kill you dozens of times over, and 99.9% of the time, you don't even notice. 8 different types of white blood cells are patrolling your body right now. And remarkably, your immune system sometimes becomes your biggest enemy, killing more people through overreaction than the diseases themselves. But I guess we'll save those immune mysteries for another video.